Good morning, children. Today we are going to study about parallel lines and transversal lines. That is from the chapter Lines and Angles. So, to understand parallel lines and transversal lines, we need to understand the figure first of all. How does a parallel line looks and a transversal looks, isn't it? And I think you all have gone through the same topic in your previous classes also. So if two lines in the same plane do not intersect when produced on either side, then such lines are said to be parallel to each other. Or we can say, in other words, two lines are said to be parallel if their perpendicular distances are same everywhere. You can take the example of a railway track or some kind of pattern where the parallel systems are used and the perpendicular distances are equal everywhere. Okay, so look at this line L and M. The perpendicular distance between these two lines, this is a perpendicular distance, is equal, right? Perpendicular distances are equal here. Here line L and M are parallel to each other. A line that intersects two or more straight lines at distinct points is called a transversal line. So it is nothing but intersecting two lines at two distinct points. It can intersect two lines or more than two lines also. By looking at this figure, the line M and N are not parallel to each other. They are not parallel, but the transversal is intersecting this particular line. Okay, so if I'm taking more than two lines, this is one, this is two, this one is three. Three lines I have taken. And if I intersect these three lines by a transversal, a line, another line, this line is known as transversal T. Okay, so this is L, M and N, and I'm taking this as transversal T. This line is called as transversal T. So when a transversal intersect two or more than two lines, it forms some angles. We are taking a pair of lines here. Let's see what all angles we get from here. First of all, the interior angles and then the exterior angles. The interior angles is this region. This middle region between L and M is called as interior angles region, where 4 and 6 is there, 3 is there, 5 is there. And exterior part is this region, 1, 2 and 8, 7. This is the exterior part, right? And the pair of angles formed when the transversal intersects two lines are as follows. The number one is corresponding angles. The angles on the same side of a transversal are known as corresponding angles if both lies either above or below the lines. That depends upon the positional angles. So this is above the line to the left hand side of the transversal on line M, and the 5 number angle is to the left hand side of line N intersected by the transversal, the same side, right? So 1, 5, 2, 6, 4, 8 and 3 and 7 are the corresponding angles. Next one is alternate interior angles. Alternate means cross angles, and they're talking about interior region. So we talk about this interior region. If you look closer, angle 4 and angle 6 are interior alternate angles. Angle 3 and angle 5 are alternate to each other, so they are alternate interior angles. The pair of interior angles on the opposite sides of the transversal are called alternate interior angles. So angle 4 and 6, 3 and 5. About the exterior, alternate exterior, 1 is alternate to 7 and 2 is alternate to 8. So this is opposite to each other, 1 and 7, 2 and 8. That goes with alternate exterior angle. And interior angles on the same side of the transversal is also called as consecutive interior angles, or simply in short we write CO.int and angles. This is called as consecutive interior angles. Angle 4 and 5, if you look here, angle 4 and 5. On the same side of the transversal, angle 4 and 5 and 3 and 6 They are the consecutive interior angles. Okay, so here we see that the lines M and N are not parallel to each other. What happens if they are parallel to each other? Suppose M and N are parallel, then what will happen? So in that case, we basically try to get into the proofs and theorems as well as the axioms. All right, so when the two lines are parallel to each other, like M and N are parallel to each other, and it is intersected by a transversal T or L, suppose this is T, then we get four angles at two distinct points. Point number A here and point number B here, 1, 2, 3, 4. And at point B, we have angles like 5, 6, 7, and 8 respectively. So the first axiom is, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This axiom is known as corresponding angle axiom. So when we talk about two parallel lines, and if it is cut by a transversal T, then in that case, the corresponding angles are equal. 1 equals to 5, angle 2 equals to angle 6. The case arises only in which case? When the lines are parallel to each other and the transversal is intersecting at two distinct points. Okay? In the previous diagram, in this case, we cannot say angle 1 equals to angle 5, or 2 equals to angle 6, or 4 equals to angle 8, and 3 equals to angle 7. It is not so sure here. So when it is parallel to each other, then only we can say that the angles are equal to one another. Okay, so in that case, corresponding angle axiom, okay, so when line L intersect two parallel lines M and N, then we see that each pair of corresponding angles are equal. So we can say that from the diagram, angle 1 is equals to angle 5, angle 2 is equals to angle 6, angle 4 equals to angle 8, and angle 3 is equals to angle 7. They are the pair of angles and they are equal to each other when M is parallel to N. The concept has arisen from the Euclid Playfair axiom, postulate number 5. You will be able to understand this clearly and more efficiently when you study about the chapter Euclid's geometry. That is again in class 9th only. So once you go through that particular axiom, you will get to understand this particular thing little more better. Okay, so why this particular, like how can we say that a transversal T is intersected and on the same side the consecutive interior angles? Okay, in this case M and N side, okay, this side, the left hand side, the consecutive interior angle, some angle 4 plus angle 5 is less than two right angles, that is 180 degree, whereas in this case the sum of 4 and 5 is equals to 180 degree. So in Playfair axiom, that is postulate number 5, you will learn about this. Okay, and from here the parallel line concept has arisen. The consecutive angle sum is 180 degree. All right, so that's all from today class. We'll learn more about the theorems included in this particular topic in parallel lines and transversal in our next class. Thank you.